I'm going to show you how to solve the binary tree maximum path sum problem in Leetcode. So the question with this problem is, how do you find inside a binary tree the path that yields the highest sum? So for example, you see in this case you have this 1, 2, 3, then the best path would be taking all of these. In the example 2, you see that because there's a minus 10 here, you actually don't want to take the higher route. You want to take this one to avoid this minus 10. I like to also show a third test case because I think it shows another issue better. So here in this case, so basically this is the same tree as this one, but here the 10 is a positive. And notice how here we want to take this path, but we can't take both paths. So when we are calculating this, we really need to make sure that we are only taking one path and not both. So this is obvious here, but I'll show you how this is important when coding this. So the solution I found for this was to basically, the first thing you do is that you want to recursively iterate, recursively visit each node. Then once you're in the node, you want to check the value of the node with the child branches. And then if the value of the node and the child branches is higher than the max value you saw, then you update the max value. If not, you return the best branch. And this is again important because you don't want to return the value of the entire branch, so the node plus the two branches. You only want to return the node plus the best branches because the path above only wants one node because you can't actually go through two of them. All right, so first of all, let's see how we can leave this as it is now, and we can make a recursive function. Okay, and then the recursive function will take a root node, will take the current sum, and we'll take the max sum. Note that we don't want to check the path, so we don't need to return the path. We only need to return the maximum sum. So we don't actually need to keep track of the best solution and the best possible solutions, and this makes the solution faster. All right, so the first thing we want to do is to check whether the root is none. If the root is none, then we just return 0 because there will be nothing that we can add to the solution. If not, we add the current value to the current sum. Note that this can be a negative thing because the value can be negative, but if we want to go through a node, we are going to have to add up the root node anyway, so we're just going to add it irrespective of whether it's positive or negative. And then what we want to do is to check the left and right paths. So the left sum is going to be, we're going to call the same function again, so rec search, and then you call root.left, and here you actually want to start from 0 again because you want to make it possible for the sum of the node below to be higher than the current sum. So for example, if you are here and you check the right node, you want to make possible that the sum of this is higher than the sum of this. So you always start at 0 and then you add the return value. And then you also forward what the current max sum is, and then you do the same for right sum. So you do rec search sorry, root right, 0, max sum. All right, so once you have these two, you can get the candidate sum. And so at the beginning, the candidate sum, so candidate sum basically calculates the value of the best candidate to return upwards. And at the beginning, candidate sum is the same as the current sum. But what you do is that then you say, okay, if the left sum is, well, actually we're going to calculate the current sum at the moment. So you say if the left sum is higher than 0, then current sum equals left sum. So basically you want to add left sum only if it adds something to the sum, and the same for the right sum. So you only add something if it's adding value. All right, and then you check whether the current sum is actually larger than max sum. Actually, we'll initialize this later, but max sum is going to be an array so that you can keep the max sum between the values. If you don't do an array, you just pass a copy each time, and then the copy the value doesn't get passed. It only a copy gets passed. So this is an array just so that we can bring the value back across the stack when we start returning. So yeah, if the current sum is higher than the max sum, then we're going to assign the current sum to the max sum. And then we have to check two things. So now we're going to calculate the best candidate to return upwards. And so at the moment, the candidate sum is just the current sum. But now we are going to check if it makes sense to add the left and the right parts. So now what we want to do is to say, okay, if the left sum is larger than 0, but also if the left sum is larger than the right sum, because notice that we can't add both, okay? We can only add one to the return. So then you do candidate sum plus equal left sum. If not, then you need to check whether the right sum is larger than 0 and the right sum is larger than the left sum. Now that I think of it, I think maybe we would need to add an equal. I'm not sure, but it could be that if you're doing it like this, there could be a point where a situation where right sum and left sum are the same, and then you don't add any. So I think it makes sense to add an equal, because then if right sum and left sum are the same, at least it will choose one of them. Both are the same, so it doesn't matter what the equal is. So then you do candidate sum plus equal right sum. All right, and this is it. And then you do return candidate sum. Okay, you don't want to return the current sum because that includes both branches. You only want to return the candidate sum. Okay, and then how do we start this function? So to start this function, the first thing that we do is that we start max sum, and we need to start it as a list, and then we'll start it with a minus infinite value, because if all the values here are negative, we still want to find the path with the highest value. So we put it as minus infinity so that the algorithm will still work. And then we just call this function once at the root node, so at the first node. And then, and then the sum is going to be 0 at the beginning, and max sum is going to be max sum. Okay, and notice that because this is an array, the value is actually going to get passed back. And then we can return max sum. Okay, so yeah, this should be it. Let's try for this case. Yes. So here, for example, for this tree is going to return 54. Let's try, for example, this one, which is the same with a minus 10. And you see that it returns 42. Okay, we can submit this to check that all the test cases are passing. Yeah, and you can see that actually this solution is probably the fastest solution that is submitted. So it's 96% faster than Python 3 submissions, and it's the most efficient solution also in terms of memory. So I hope this was useful, and if you have any questions, you can leave a comment. Thank you for watching.